So here we have three regions of operation, that is for NMOS also, NMOS or PMOS. Basically, we have three regions of operations will be there. And what here important is these equations which are given here for cutoff, and this is for cutoff region. Triode means it is nothing but a non-saturation region, also it is called a triode region, it is called, or sometimes it is even called as linear region. So this is, we can say it as non-saturation region. Okay, this is non-saturation region or triode region or linear region. Even you can call it as a resistive region also. And the third region of operation is going to be saturation region, right? So if you compare the equations for these two, NMOS and PMOS, they VGS is less than VTN, and here mod VGS is less than mod VTP. I'll tell you basically the things which you have to remember is whenever VGS, it is going to be positive for NMOS, the transistor is going to be on. Okay, so VGS is going to be positive. VGS is positive for NMOS. VGS is positive for NMOS, and VGS is going to be negative for PMOS. VGS will be negative for PMOS. That is, at the gate, we are going to apply the negative voltage. The gate, we apply the negative voltage to the source in case of PMOS. And here, whenever we take the magnitudes, so the sign has nowhere now comes into picture because we have taken the mod. That's why the VGS less than the threshold voltage of NMOS VTN, then the NMOS transistor is in cutoff region. Similarly, mod VGS less than mod VTP, then the PMOS will be in cutoff region. If you take with respect to the negative voltage, suppose we take the VTP is equal to minus 0.5 volts. That is, whenever the input negative voltage is -5 or less than -5. Less than means more negative. So that is for the PMOS to become on, the input voltage should be minus 0.6 or more negative than minus 0.6. So if you consider this condition of linear region or non-saturation region, here we have, that is mod it is taken. So if you take mod VGS, it is going to be plus 0.6 volts, plus 0.6 volts. And VTP also, we take mod VTP. So mod VTP is going to be plus 0.5. That means what? Mod VGS is 0.6, that is greater than our mod VTP, greater than mod VTP. So once this is applied, that means VGS is more negative than the required threshold voltage of minus 0.5. And also another condition that has to satisfy is mod VDS is less than mod VGS minus mod VTP. I'm explaining here with respect to PMOS because NMOS already we know. I'll explain that also with respect to NMOS. Mod VGS is greater than mod VTP magnitude wise with respect to VGS. Suppose we apply VDS at the drain, we apply negative voltage for PMOS. Suppose we are going on increasing the negative voltage, and starting we have applied, that is to drain we apply negative voltage. Suppose minus 0.5 or minus 0.3 volts we have applied at the drain. Okay, hole starts attracting towards the drain. Holes will start attracting towards the drain, right? And if you consider with respect to magnitudes, mod VDS is how much? Mod VDS is plus 0.3 volts. Okay, mod VDS is plus 0.3 volts. And if you consider the mod VGS minus mod VTP value here, mod VGS and in the table, the diagram which is given at the table, mod VGS, minus mod VTP. If you calculate what is mod VGS and mod VTP, mod VGS, it is point, uh, 0.6, okay, 0.6 it is, minus, and if we consider the mod VTP, it is going to be 0.5. Mod VTP is 0.5. So mod VGS minus mod VTP, it is 0.1. Okay, 0.1. So if you compare with respect to magnitudes, this mod VDS is greater than our mod VGS minus mod VTP. That means if you observe, this is going to be the third case in which the transistor operates in saturation region. Suppose if you take another values for VGS is going to be minus 1 volt. This is for PMOS, and our VTP is going to be minus 0.5 volts, and VDS, okay, VDS, suppose you take it as minus 0.3 volts. Now, if you take the mod VDS, if you take mod VDS, if you take here, so what we get, plus 0.3 volts you're going to get. Okay, next, mod VGS minus mod VTP, suppose we take mod VGS minus mod VTP, if you take, so what we get here, it is mod VGS is minus 1, mod VGS is 1 volt, minus mod VTP is minus 0.5 is VTP, mod VTP is plus 0.5. So here we get 1 minus 0.5, it is going to be 0.5 volts. 0.5 volts we get, right? So if you compare the relation here, the VDS, mod VTS is 0.3, which is less than our mod VGS minus mod VTP. So this is the second region of operation, that is triode region or non-saturation region, linear region, resistive region. Okay. And now what are the equations you have to use here is, these are the equations which will be used to calculate the linear region or non-saturation region currents. Mod VGS minus mod VTP minus mod VDS by 2 whole into mod VDS. Okay, and this is the equation you have to use here, and here it is given Kp. Kp is nothing but it is beta P. In this case, generally we write Kp dash. Kp dash is different, Kp is different. Some books give it as Kp dash. Kp is nothing but Kp dash into, we have W by L. That is nothing but beta P. Okay. So that is, these values will be given in the problem. Kp dash they'll give, W by L value they'll give. You have to calculate beta P or Kp and substitute in this. VGS they'll give, negative voltages they'll give for calculating the current in PMOS. Now coming to the NMOS, as it is simple, VGS less than VTN, the NMOS is off, IDS is equal to 0, and VGS is greater than VTN, and VDS is less than VGS minus VTN. The transistor operates in non-saturation region. The equation already we have discussed, is little easy compared to PMOS. Similarly, VGS greater than VTN, VDS is greater than or equal to VGS minus VT. Then this is the equation which you have to use. Kp is for PMOS, and here it is Kn by 2. Kn is nothing but beta n, which is Kp dash into W by L minus VTN whole square. When it comes to the PMOS, here you're going to use mod VGS and mod VTP you're going to have. Okay. Now, the regions of operations which we have seen, regions of operation of NMOS transistor we have seen, that we'll discuss now. So the PMOS transistor, here we have P and NMOS combination we have, which gives the CMOS. CMOS is nothing but it is not gate or inverter. Here we have the output and here we have the input, right? And now this the four terminal connection, it is N substrate connected to VDD, which is nothing but source of PMOS, and this is source of NMOS, which is connected to VSS or ground, and this is drain of NMOS, and this output is drain of PMOS also, drain of NMOS also, and here we have the gate of PMOS, and here we have gate of NMOS. Now once we apply the input voltage 0 here, input voltage 0, so we are going to get VGS. VGS is of PMOS if we consider. We're going to have VG minus Vs only. VG minus Vs we have to consider. VG is 0 and Vs of PMOS is VDD. That VDD you can take it as 5 volts or 3 volts, one power supply you can take. So 5 volts here minus 5. So VGS is going to be minus 5 negative voltage, for which the PMOS is going to become on, and PMOS is on, and VGS of NMOS is nothing but VG minus Vs. VG is 0, Vs of NMOS is also 0, 0 minus 0, that is the NMOS transistor, it is off. The four terminal of NMOS is connected to ground. So here in the first case, when we apply input 0, V in is equal to 0, we have the output is going to be VDD. How it is VDD? You have to imagine a capacitor here. You have to imagine a load capacitance CL. Once we apply input 0, the PMOS transistor is on, NMOS transistor is off, and the capacitor CL is going to charge. Capacitor CL is going to charge towards VDD. So output is going to be VDD, that is logic 1. This gives us the logic 1. Okay, when input is 0 or 0 volts, 0 is logic 0, 0 volts is the voltage level, output is going to be logic 1. NMOS is off and PMOS is on. Now on means how it is on, that is in which region it is on. Linear region or non-saturation is also on, saturation is also on. So in this case, since we have the output voltage, I'll write here, output voltage of NMOS, if you take VDS of NMOS, which is nothing but our output voltage. VDS of NMOS is our output voltage, that is equal to almost approximately equal to 5 volts it is. Okay. Now coming to VDS of PMOS, VDS of PMOS is nothing but VD minus Vs, Vd minus Vs of PMOS. What is Vd of PMOS? Vd of PMOS is nothing but output voltage minus Vs is nothing but VDD, that is 5 volts. Output voltage is also 5 volts in this case. So 5 minus 5, that is going to be 0 volts. So VDS is going to be 0 volts. VDS is almost 0, not exactly 0 it is, because here we are taking 5 volts, approximately 5 volts, almost 0 it is, or it is going to be some small voltage. So VDSP is almost 0, whereas VGSP is minus 5. So with respect to the conditions, if you consider VDSP is almost 0 and we have VGS, you can take here as the mod. If you take VGS, mod VGS is 5 volts. That will be better, easy way you can have. Mod VGS is 5 or VSG is also going to be 5 volts. Now mod VGS minus mod VTP, it is how much? VTP you can take it as 1, sorry, it is VT, right, VTP only. So threshold voltage of PMOS, you take it as minus 1. VTP, you can take it as minus 1 volt. Minus 1 volt. So VGS, mod VGS is 5 volts. Mod VTP is 1. So we get it as 4 volts. 4. So if you compare here, VDS is 0, which is less than mod VGS minus VTP. That is nothing but this condition it is satisfied. That is That is the second region of operation, mod non-saturation region, which is PMOS transistor. PMOS transistor operates in non-saturation region. Okay. Now, if you consider this is for V, now if you consider for NMOS transistor, we got VDS is equal to 5 volts. And what about VGS of NMOS transistor? VGSN of NMOS minus VTP is for P, and here we are taking VTN. So it is mod VGS. And here we have VGSN is 0 volts. Okay. 0 here we have minus VTN. If you take it as 1 volt, it is going to be minus 1 volt. So this is minus 1 volt. That's why NMOS is off. Completely it is off. Right. In this case, NMOS is off in the first case. Now, in the second case, if you consider three regions, here we can have our the middle region. Further, it can be divided into two. I will draw here this one. This is this, here you can divide this into, this is one region, this is second region, this third region, and here you have fourth, and this is going to be the fifth. So this you're going to have 1, 2, 3, 4, and here you're going to have 5, region 5. Okay. So this is going to be on the y-axis, you're going to have the current, and the x-axis you're going to have the voltage, increasing the input voltage, it is going to be there, and x-axis you're going to have the V voltage. So that is first region. Here in the first region which we got, PMOS is in saturation, NMOS is in off region. When it comes to the second region of operation, we have increased VGS, to, suppose say we have increased VGS and we made the VGS now, that is V in of this VGS, we can say V in, we make it as 1 volt, which can be VGSN, because VG of NMOS minus VS of NMOS. So VG of NMOS is nothing but 1 volt V input minus VS of NMOS is 0. So V in is nothing but VGSN, which we got it as 1 volt, which is volt. Voltage, we considering the threshold voltage of VTN is plus 1 volt. Okay, VTN is plus 1, or you can take here 0.9 only you take, because we are getting VGSN as 1 volt. 0.9 volts you take, 0.9 volts VTN. So this condition of non-saturation region where VGSN is greater than VTN is satisfied. Now if you observe this VDS of NMOS is nothing but output. Since we have increased the input and NMOS is on, the capacitor now starts discharging. Here in the right corner you see the capacitor starts discharging. Earlier it is 5 volts. Now in the first region it is 5 volts. Now it is going to start discharging. For example, we take it became as 4 volts. Okay. Now if you compare the voltages, if you write here VDS of NMOS, VD is nothing but output voltage, that is 4 volts, minus VS is ground for NMOS 0. So VDSN is 4 volts. VDSN is 4 volts, and VGSN minus VTN is VGSN we applied 1 volt minus VTN is nothing but it is 0.9 volts. So it is 0.1 volt we get. So if you compare here, VDS is 4 volts and VGS minus VTN is 0.1. So VDS is far greater than our VGS minus VTN. That is the second region of third. Second region of operation, mod non-saturation region. That is the second region of operation, mod non-saturation region. So this is second region with respect to this diagram here, and with respect to the this table which is the saturation region. So still the NMOS transistor remains in saturation region. It is on, it remains in saturation region. In the first region, NMOS is off. From off to directly it entered into saturation. In region 1, which we have seen in this diagram, in this region it is off, NMOS is off and PMOS is on. And the PMOS is operating in which region? We have seen it is in linear region it is operating. Now coming to the region 2 here, the NMOS is on, and because VDSN is 4 volts, is directly entered into saturation region. Now coming to PMOS, that is pull-up PMOS, since the output is 4 volts, suppose if you take, there will be a voltage drop across this source and drain here. Here it is going to be the voltage drop across these terminals, 1 volt magnitude we are taking here, 1 volt, and the output is 4 volts. So now if you take this VSD mod only I am taking here, that is the voltage drop across the drain source of the PMOS or source drain of PMOS, it is going to be 1 volt. Okay, VSD is going to be 1 volt. And now what is VGSP in this case? If you consider VGSP, we have mod only you take, mod if you take, there will be no problem at all. So we have mod VG minus mod Vs. Mod also you can take VG, here we are applying 1 volt. V in we have said here, you can see left side below corner, V in is 1 volt. So VG is 1 volt minus, here we have mod Vs, it is nothing but VDD, that is 5 volts. VDD is 5 volts, so approximately it is minus 4 volts. It is minus 4. If you take the magnitude of this, we get it as plus 4 volts. So here mod VGS or VSG, you can take, VSG is going to be 4 volts. So VSG is 4 volts, and voltage drop across the source drain of PMOS, it is 1 volt. It is 1 volt. So this also satisfies the second case where VDS, mod VDS is 1 volt, and mod VGS minus VTP minus 1 if you take, that is going to be 3 volts. 3 volts is mod VGS minus mod VTP is 3 volts, and mod VDS is how much we got? Mod VDS how much? This one, 1 volt. So this is less. VDS, mod VDS is less than mod VGS minus mod VTP. So the PMOS still operating in which region? Linear region or non-saturation region. First region of operation in this, the diagram below we have, it is non-saturation, NMOS is cut off. Second region of operation, NMOS directly entered into saturation, and PMOS still it is in what? Still it is in non-saturation region. Now coming to the third region where we have region 3. Okay, region 3 here we have, in which the NMOS transistor, suppose V in is increased, V in it is increased to 2.5 volts, V in is it increased to 2.5 volts, and VGSN is directly equal to 2.5 volt. VGSN is directly equal to 2.5. Right, I'm going to erase this. So V in and VGSN both are same. Remember this, input voltage is similar to our VGSN. So suppose we have increased that to 2.5 volts, right? And so VGSN, V 1 minute, the VGSN, okay? So here we have VGSN is equal to 2.5 volts, and 2.5 volts. And VDSN, since it is discharging only, the capacitor voltage is nothing but VDSN, it is discharging only. Suppose we got it as 2.5 volts. 2.5 volts is the VDSN. Now in this condition, if you observe, VGSN minus VGSN minus VTN is equal to 2.5 minus 1, that is 1.5 volts, 1.5 volts. So which is less than the VDSN, that means VDSN is greater than VGSN minus VTN. So still NMOS in the third region of operation. This in the graph, the diagram, in this diagram, the third region, it is NMOS is still in saturation region only. NMOS is first region of operation is cut off, second region it enter directly into saturation, third region also it is still in saturation region. What about the PMOS? If you observe, mod VDS I can take here, or mod VSG also you can take. VGS, mod VGS of P, it is going to be, input is 2.5. Okay, input is 2.5, and this is VG minus VS. If you want, you can for calculating the voltages VGS, you take it as, don't take mod here, VGS, you take VGSP, which is nothing but VG minus VS. This is 2.5 minus VS is VDD, that is 5 volts. So we get here it as minus 2.5 volts. So what we got, VGSP is minus 2.5 volts, right? So if you calculate, the conditions are very important. You can understand now clearly the condition what we are getting here. So VGSP is minus 2.5, and if you take the VDS of PMOS, VD minus VS of PMOS, we have what is VD? VD is nothing but 2.5 volts minus VS is how much? VS is nothing but our VDD, that is 5 volts. So it is minus 2.5. So if you take mod to this, mod VDSP, then it is nothing but plus 2.5 volts. And the mod VGSP A minus mod VTP, you take, mod VGSP is nothing but 2.5 minus VTP. Suppose you take 1 volt or 0.9, also you can take 0.9, you take what, it is not a problem. It is going to be 1.6 volts. So if you compare here, VDSP is greater than our mod VGSP minus VTP. So which region it is operating, you can tell? It is operating in saturation region. Okay, this here it is operating in saturation region, that is third. The highest current will be highest peak. This exists for only very short duration of time. Okay, third region. Now coming to the fourth region and fifth region, here we have, okay, now suppose we have increased the input further from 2.5 volts we have considered. Now from 2.5 volts further we have increased the input voltage. Further we have increased the input voltage. Suppose you take it as our V in, we made it as 3 volts or 3.5 or 3 volts, and output we take, output is nothing but VDSN, and V in is nothing but VGSN. Okay, VDSN is nothing but the output voltage of the CMOS inverter itself, and which is VDSN, that is of NMOS. And it is, suppose we take it as 2 volts, because input is for longer time it is high, and the capacitor discharged more. Okay, and suppose take this is to understand the condition. Suppose take this as 1.5, 1.5 only. It will be 1.5 volts, 1.5 volts. Maybe zoom will end. So 1.5 volts it is, right? So in VGSN, minus VTN, if you take, that is 3 minus 0.9, it is going to be 2.1 volt, which is greater than our VDSN, greater than VDSN. So the transistor, NMOS transistor, is now entered into linear region or non-saturation region, that is in fourth region. And coming, since the output VDS 1.5 and VDS of PMOS is nothing but VD minus VS. So VD is how much? VDS, it is nothing but 1.5 output, minus Vs is 5 volts. So it is going to be minus 3.5. So if you take the magnitude, VDSP is going to be plus 3.5, and this is greater than our mod VGSP. You can check here, minus mod VTN. So the, in which region the transistor PMOS is going to be? In the fourth region, it is the transistor NMOS entered into linear region and the PMOS will be in saturation region. But overall, since the current flows from VDD to VSS, both are in series, very small current will be there in the fourth region. Now coming to fifth region, input is very high, so PMOS is completely off and NMOS is going to be in linear region. Okay, right. We'll stop this record.